Hi, we're live and you're watching Test Containers Live. Today is a very exciting day and we have the one of the most knowledgeable guests in the whole Java ecosystem. And it's my pleasure to introduce and welcome Cédric Champeau to our live stream. Hi, Cédric. How are you?
Hello, I'm very good, thank you, and thanks for the invite.
Right, let me just check. Yeah, I think everything works as expected. Yes, it's my pleasure to host you here. If you don't know Cedric, he works at Oracle Labs in the GraalVM team, and he works on the Micronaut Framework. He is specializing in developer productivity tooling, which is very close to every developer, right? So, like, touching a lot of developers' lives. And he maintains the official GraalVM and Micronaut plugins for Gradle and Maven, which is which is which is very up your ante because before you worked at Gradle on the open source build tool. And I know that in my personal kind of hierarchy of champions of Gradle, you are very close to the top. You are the expert for me. And you also worked on the Apache Groovy language and implemented static
Yep.
compiler and some features about around DSLs and AST transformations. So a lot of experience, sort of from different parts of the ecosystem, but all of them sort of focusing on the tools and a little bit on developer experience, like immediately touching and working with developers. So you have quite a bit of experience. And here's my first question to you. What do you think makes a great developer tool? Can you put it in a few words? What's a great tool? Is it like popularity? Is it flexibility, robustness?
I don't think this is popularity. Popularity comes after. For me, what makes a great tool is mostly about solving a problem, but in such a way that you basically change the way you work. Like you have this tool which enables a new landscape of possibilities for you to do. Like I don't know, you work at test containers, so imagine just this feature like you have functional tests and they take 5 hours to execute, whatnot. So basically, if you're a developer, this is extremely frustrating. So if I can offer you a tool which says, okay, I'm going to reduce that from 5 hours to a minute, it's basically going to change the way you work. And this is where, for me, tooling is super important. Like tooling should change the way we work in the way that we improve the quality of the products, we enable new patterns, etc., etc. So this is, yeah, in a few words, what I think a great tool should be. It should be about, in our domain, developer productivity first.
Right. And following up, like you had the whole ladder there. You started with the programming language,
Yeah,
and then the build tool, and then in the application framework, right? And then normal, I would not say no one to say normal, but developers built on top of those layers. What is the most rewarding layer to work on personally for you?
uh, that's an interesting question. I wouldn't say there's a more like interesting layer. It is just by accident that I started working on all those different layers. It was really, really interesting to work, yeah, for the Groovy language. Typically, a few years ago, I just came that because I just started to work with Groovy because I was developing an application like any developer, and I had some requirements, and Groovy was there with this DSL thing, which really helped in this context. And I had to fix some bugs in Groovy and implement some new features, and this is how I came into that. And it was rewarding by itself to work in this tooling, but not because it was tooling, more because you know it was an open source project, and I had the opportunity with my work to actually improve the life of many developers. Like this is the scale which is rewarding. So if you work on a language, obviously you can have a very large scale because you have a wide variety of different applications which can be built on top of a language. But working on build tools is another landscape of problems that you can solve, like have faster builds or whatnot. But the framework part is still something new for me. So just for the record, I think I joined Oracle Labs like a year and a half, maybe. Yeah, if I remember, actually, I joined, and maybe 1 month after you left. So I don't know if there's a correlation that you left after I joined Oracle Labs, but anyway, so yeah,
Yes,
this
scratch
this
that.
framework thing is really new to me, and it's interesting because I am seeing lots of different areas that I was never seeing before. Like there's so many integrations to implement and things like that. And but what I'm interested in really is making things easier for developers, whatever it is. Like if it's I could work for an IDE or whatever. It doesn't really matter for me. And as I said several times, I'm not even married to any particular technology. I mean, if something does the job at one point in time, it could 10 years from now not do the job anymore because new technologies come, etc. So we have to embrace the changes and just yeah implement what we have to implement to make the lives of developers easier.
Right, right. That's smart. That's smart. I think there is the one constant thing is change,
Yep.
definitely, and we should not have all our bets on the particular thing. Well, there is always the opportunity to go into legacy and
Yeah, and in any
work.
case, you still have some background. I mean, the everything I've worked with for the past 10 years is all in the Java ecosystem in general. So
Yeah,
there was
well,
Groovy,
it's
but it was
also
in the JVM ecosystem. So yeah. So I'm
and it's
still in an area which is the JVM ecosystem.
right. Let's talk maybe briefly about Micronaut, which
Mhm.
is what you're currently working on.
Yeah.
It's a very interesting framework. Can you maybe say a few words about what's the sort of the cornerstone of Micronaut philosophy? Like, how is it different from everything else that is on the market?
hmm So Micronaut, so you probably heard about Rails a few years ago, which was based on Groovy and was a framework which was inspired by Rails. And the idea of this framework was basically to improve developer productivity again, but it was for that leveraging um, the Groovy language and dynamic runtime and its capabilities, etc., etc. And it worked. It worked really well, and actually, there are still some releases of grades today. But there was a cost, like the application is slower because it has to do a lot of things at runtime. It would, like a typical Spring application, involve some proxies at runtime, so some overhead here and there, and all in all, the technology is not as fast as it could be. So the idea behind Micronaut was basically to start from scratch and take the ideas of the frameworks, like the productivity ideas, like annotate, class with at entity and generate things. But instead of doing all those things at runtime, we try to do that as much as possible ahead of time so that you pay the price basically when you build the application, but not at runtime when you execute it. And this is super important in our new world where basically you develop applications which are microservices, where you have limited resources in the cloud, like limited memory, limited CPU, etc., etc. So you have to have applications which start as fast as possible. You have to have applications which don't use much resources, and you want to be productive when you develop those applications. So Micronaut is really about that. So it's embracing this new world, which is microservices, functions, and build a framework which is enjoyable.
Right. Do you have a sort of a favorite module or like a favorite feature in Micronaut? Because there are
Mhm.
there are like and I know a little bit about of course I
Yeah.
know a little bit about Micronaut, but there is a like the whole different parts of the framework are kind of fit into that ahead of time compilation and runtime efficiency philosophy, right?
Yeah.
I don't know, JSON marshallers and I don't data access and all of those things. So do you have a favorite or?
Yeah. Yeah, Micronaut is built in such a way that it is actually very pluggable. So the core of Micronaut is actually not has nothing to do with microservices or whatever. It is basically a dependency injection mechanism at build time, a bit like Dagger. If for people who know about Dagger, it was kind of the the mindset there. So you have different modules which are built on top of this core, and you can build applications like for the CLI or for the cloud, etc., etc. And then you have different modules. And I must say that one module which is particularly impressive for me is Micronaut Data, which is something which I'm going to show you a demo a bit later. So you're going to actually see that in action. But the idea is that you have your entities, yeah, like you have a person entity and you annotate that, and then you need to access that in such a way that it's easy for a developer to call the database and store entities, retrieve entities from the database. And for that, you just basically create an interface, you annotate it with at repository, and then Micronaut Data would generate all the methods to access the data layer for you. And the very nice thing about that is that you would get instant compile time feedback if you make some mistakes. Like I was mentioning this Graze use case before, and I'm going to give you an example there. Like repository methods are not new in the Java ecosystem, but if you have a repository, say you have a person and it has two properties, name and age. So typically, Micronaut Data would generate a method like find by age automatically for you. Like you don't have to implement the SQL query, or you don't have to implement the Hibernate queries if you use Hibernate under the hood, etc. And all you have to do is to create this find by age method. But if you make a mistake and in your interface you write find by ages, like you put an S, an extra S, there's no property named ages in your person class. So you would get this feedback instantly at compile time. So the idea is really to have the feedback as early as possible and not at runtime and have a method which is missing. And this is for me one of the biggest advantages of Micronaut is that because we move everything we can at compile time, you get this feedback almost instantly, and you can even get that within the IDE without compiling. So
Right.
that's really impressive.
Out of curiosity, I've seen Graham doing a bunch of demos using VS Code. What IDE do you use daily? Like, what's
So
your
I
main
use
IDE?
IntelliJ daily. I have tried to use VS Code, but I'm so used to the shortcuts and features of IntelliJ that it's it's damn hard to use something else.
Right. Yeah, the same boat. In the same boat here. My my muscle memory is all I got,
Yeah,
and
but
it's
we
not
have
even
really excellent support now for VS Code for Micronaut. So typically, what I'm saying, like these errors, like if you make a mistake in your interface and use a property which does not exist, if you use VS Code, it would tell you directly in VS Code.
mm,
If you use IntelliJ,
I
you have to compile to get the feedback.
oh right, uh, which is great. Which is great for the application developers specifically.
Yep.
And I know that like there are plenty of people working on the VS Code plugins on the GraalVM team and Micronaut teams.
Yes.
So
Yeah.
that will get better and better. I'm
Exactly.
pretty
Yeah.
sure of that. Uh, while we have a little segue here, there was a question in chat. There, do you like a picture behind you? Is it of
This
one
one.
of yours? Yeah,
It is one of mine. Yeah. 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 So I do.
right. So
Yeah. I do astrophotography. So this is one of mine.
do you do it fully manually, or is there like a microservices setup that positions the camera at the correct
So
angle?
I'm a Linux guy, but for astronomy, this is the only area where I'm actually using Windows because there's this are some software called Nina, which is nighttime imaging, astronomy, whatever. And this is software which actually drives the whole setup. Like it's going to connect to the telescope, point automatically, do the focusing, etc., etc. So some would say it's cheating, but it's actually super important, especially in my area because we have like rain quite often. So you don't
Yeah.
want to spend hours trying to get the right angle or whatever. So you want to automate as much as you can and then do the processing. So
Right.
yeah, no, it's automated to to get the telescope in place, but then everything is manual.
Nice. I've seen you post a couple of pictures on Twitter, and if you're watching us and you haven't followed Cedric on Twitter, you can just do that. He goes by at Cedric Champeau. Uh, just yeah, and you get a chance not to just get a glimpse of the wisdom on various software engineering topics, but also an amazing photos of the night sky, which will hopefully brighten your day. How
I
ironic
hope
that
so.
sounds. Right. Uh, Talking about beautiful things, let's just we cannot avoid. I cannot avoid this. I cannot avoid this. Let's talk a little bit about native image
Hmm.
from GraalVM native image, because this is a big part of what you were working on initially to enable better support for that in Micronaut.
Yep.
Um, and there are a lot of information about that, and there are excellent presentations by both the team and external people and the uh, application frameworks developers. It's getting more mainstream and more kind of sort of, I don't know how popular, but like people know
Yep.
where to get information. And still, there is a lot of misconceptions about things, like still people think that reflection might not work or stuff like that. So here's
Mhm.
a little bit of a tricky question. What's the hardest part of working with native image to you? Obviously, your personal opinion, and like what's the hardest to make work in it?
Right. So maybe we should start with just a reminder of what native image is, because maybe
Oh
not
yeah.
everybody knows. But so GraalVM has this, it's a wide project, but one small part of this is native image. In a nutshell, it's about compiling a Java application into a native binary. And so it's moving this from the JVM, the runtime, to a small executable that you have locally. And when we talk about Micronaut, Micronaut has support for native image out of the box, which means that if you generate a Micronaut project and do a native compile, like you get this automatically. And so the question was, what is difficult today, basically, with a native image? And I would say it's much easier today than it was like a couple years ago. Much easier. So what you mentioned. So I'm working on the Gradle and Maven plugins for GraalVM native image, and this is officially supported. And part of my job when I joined Oracle was to move the ad hoc support that we had in Micronaut and that also the Spring folks had in the Spring plugin to a community plugin which can be used by Micronaut, Spring, potentially Quarkus. They don't yet do that, but they could use that. So one plugin supported by us where we solve all these problems. And the reflection problem that you mentioned is one that we recently solved somehow by making it much easier to use the GraalVM agent. So with the latest releases of the native image plugin, typically all the configuration that you have to write to get all the reflection data so that your application works and doesn't blow up totally with a mysterious error message when you start that. Actually, you can get rid of most of that just by adding a -p agent on your compile command line, and it would automatically spawn the GraalVM agent for you, which would introspect your application. You would exercise the different use cases, either with test or just with automated testing, whatever. And then what you get is the configuration files automatically generated for you, and then you can compile your application with that. So so reflection data, GNI, all this is much easier to handle today thanks to this plugin. So that's one aspect. And the second one is that we recently opened a new community repository. So if I remember, it's on GitHub slash Oracle GraalVM reachability metadata. Well, I could paste the link to the repository later. But this is basically a repository of configuration for all the libraries in the wild which do not officially support GraalVM native image. Like you have this library that you use in your project, which is using reflection. And I don't know, the maintainers of that project don't want to support GraalVM native image because they don't have the bandwidth to test and whatnot. So instead of asking them to do that, what we offer is a way for the community to write the configuration files and publish them to that repository so that everybody benefits from this configuration. So if you are familiar with the GraalVM ecosystem, basically this is what the Quarkus guys are doing. Like this is what the Spring guys are doing. This is what we do at Micronaut. So everybody has in their framework configuration files just to handle netty, configuration files to handle lockback, whatnot. So instead of everybody writing their own config files, what we want to do is to have one single source of truth for all those libraries and share that so that it's less painful for users to use that. So
Nice.
yeah,
That's, I think
it was
that
quite
was a very big effort
complicated.
to make that repository happen, because
Yeah,
it involves a lot of communication, and I hope it will take off.
yeah,
Uh,
yeah. So it's really in the beginning of the project like that. Not many libraries yet, but hopefully this is going to grow.
right. Yes, I would love to see that. So you mentioned one thing, right? You mentioned the configuration agent, and you
Yeah.
said that one of the most natural. No, you didn't say that, but that's what I heard. One of the most natural ways to exercise that is to run your test suite with the
Yeah.
agent, and then because it records the configuration for the code paths that actually are taken, right? So
Yeah.
what I take from there is having like a test suite that you can trust, um, is very important to application developers.
It
Let's
is, yes.
let's let's talk about tests maybe then,
Well,
uh, a, li- a
yeah,
little bit.
you should write
Uh,
tests.
yes, Cedric says, like people on YouTube, Cedric says you should write your tests and you should run your tests, and having more tests are better than having fewer tests, proper
So
tests.
I would
Right.
have some opinions on whether you should write unit tests or functional tests. I am more of a functional test guy rather than unit test personally. But yeah, as long
Music,
as you have tests, this is fine.
music to my ears. I also share the belief that maybe higher level tests or uh, bring more confidence to the project. So, and this is one of the main virtues of having good test suite, is to have the confidence that when you want to release stuff, that stuff works, which is great.
Yeah.
And this is also, you worked on a very exciting to us project very recently that sort of culminated in the release in the last months or so, which is Micronaut Test Resources.
Hmm.
Uh, can you tell us what it is, how one should think about that, and maybe show a little
Yeah.
demo how it works?
Yeah. So Micronaut Test Resources is really a new module. So it started in Micronaut 3.6. And the idea is to make it even easier to set up your environment for running your tests. So we were just mentioning functional tests, and this is a good example because when you run your test, you're going to have to connect to your database. And how do you say, okay, use this database for tests, and how do you set up the initial database? And for that, you have a couple of options. In general, like either you have a wiki and you list, yeah, please developer install this Postgres database, create this user, etc., etc. And maybe if you're lucky, the guy or actually created some Docker image to make it easier to set up. So that was the old way. And the other way was to actually use test containers for that. And test containers is actually super nice because it helps in setting up these. Um, well, it really helps in terms of setup, because what you basically do is that you declare in your test that I'm going to use this container, and then it takes care of spawning everything in the lifecycle and whatnot. And that's great, but it comes with some price in terms of what you would write, in terms of dependencies, in terms of test setup, etc., etc. So you would have to handle that. So we looked at what the competition was doing to make things easier, and we looked at in particular what Quarkus was offering there, and they had this thing called Dev Services, and that was, when I first saw that, was like, whoa, this is really nice. Like, it solves so many problems. Like, you don't have to care about setting the GDBC URL or whatever. It's going to do that for you. And the idea for us was to provide a similar experience as what Quarkus does, but also to have, I would say, different implementation which solves different kind of problems. And so I'm going to show that in the demo, but basically one of the important bits for us was to isolate as much as possible the test environment from the class path of the application itself. Like, we don't want, I'm going to give a dummy example, but I don't know, you have these test containers, Redis library, which is going to bring Redis on the class path. And maybe because Redis has transitive dependencies on Guava, this is absolutely not the case, but maybe it has. This could interfere, with your own libraries that you want to use in your application.
Right.
So that's one aspect. The other one is that we have this built-in support for GraalVM, and if you run native images, this is not against test containers, but if you use test containers with GraalVM, it is still a bit painful to set up. Like, you have to generate all those configuration files, etc., etc. So this was something that we wanted to fix and to isolate properly.
Yeah, I agree. You don't want to compile into the native binary your tests that involve like
Yeah,
setting up your environment. Uh, One could argue that the proper setup is to use tests in Java, like a normal Java process, and spin up the native image of your Micronaut application in the Docker container, because that will start in like a few milliseconds,
yeah,
and then have the high level functional tests. But
yeah,
I completely agree with the point that bringing uh, sort of uh, test ClassPass libraries into native image is not something that you want to do lightly.
yeah.
Right.
So it's going to be easy if I actually show you a demo. So it's going to
Yeah,
be more
I'm
speaking,
all
I
up
guess.
for it.
So I'm going to share my screen, and I'm actually going to give you a short intro of what Micronaut is in the process. So so if you want to get started, well, if you don't know Micronaut and want to get started, the easiest is actually to go to this URL, just micronaut.io/launch, and there you have a UI which would let you generate a sample project. So in this case, I have prepared what I want. I'm going to change the demo name, like we're test container live. So I'm going to use TC live as a name. So you can pick up some features, and in this case, I have chosen to use Postgres and the library I was mentioning, so Micronaut JDBC data. I'm going to use Java 17. My build tool is going to be Gradle with the Kotlin DSL, and I'm going to use JUnit for testing. So something nice in Notion is that you can actually preview whatever is going to be generated, so you can look at the build files, etc., etc. And you have several options when you're going to generate a project. One is to push to GitHub, which is actually pretty nice, but in this case, I'm just going to download the zip file. And let's open that in my favorite IDE. So I'm going to use /temp, close, and let's open that into my IDE. So TC live should be there. Are you there? No, it's not. What did I do wrong? Let's go. Maybe because we're sharing, it's a bit slower to show up. TC live, it's there.
Perfect.
Okay, so you can see that if I actually import that project in IntelliJ, what it's going to do is immediately import that. So I don't have to do anything particular. It's going to recognize that it's a Gradle project. You're going to have the completion there. So it's a build script, Gradle build script. And yeah, it's actually pretty nice that it works out of the box. But if I look into this, the only thing that I have is just a standard Micronaut application. So if I run this, it doesn't do much. It's just going to invoke Gradle, and it's going to complain because I don't have any data source or whatever. So we're going to just do something there. So I'm going to create, let's say, a book record. And as I was mentioning, so it's Micronaut Data that I'm using. So I'm going to use a mapped entity, and it offers me the ability to say that I'm going to use the ID annotation, generated value. Say I'm going to use long ID and then just the title. So records in Java 17 it's pretty nice because you can basically just do that and you have all the setters getters for you. So
And
this is my entity.
in Micronaut Data, you can use records as
Yeah,
entities,
yeah,
even though they're immutable and
yes. Yeah, the
sometimes.
only drawback if you use a record is that you have to make this ID nullable, because
Okay.
otherwise you wouldn't be able to use that. So now that I have my book entity, I'm going to create a book repository. Yeah. And this is exactly what I was mentioning before. So I'm going to use the @gdbc repository annotation, and I'm going to say that I'm using the dialect Postgres. So this is going to be a Postgres database, and it extends a CRUD repository. And the type is for a book, and the type of the ID is long. So just by doing that, I'm already having some methods generated for me. So if I look into the CRUD repository, you have save, update, etc., etc. But what I want probably is a method like I can do optional book find. Come on. Optional find by title. I'm going to bring a title. That's the only thing I have to do. Oops, I'm not in the right class. Should have told me I was not in the repository. There you go. So the only thing I've done is just adding a method find by title. And now, of course, what I want to do is generate a test for this, right? So I'm
Absolutely.
going to create a book repository test. And this is where Micronaut comes in action. So I'm going to annotate my test class with @Micronaut test. And I am going to create just a test saves book test. So I need to annotate that with @test. and I'm going to inject my repository. So book repository. There you go. This is Java, so I have to use semicolons. Sorry, I'm used to using Spock. So now I just have to write my test. So I'm going to create a book equals new book. So I'm going to use null as the ID from now. So that's what I was mentioning, that if you use a record, you have to make it that nullable. And then hello test containers. And now I want to save that book. So I can do that save my book. And I'm going to call that saved book. And of course, because this is a test, we want to do some assertions. So I'm going to do asset not null saved book dot get ID dot ID. Sorry. There you go. Import that. Right. So this is basically all I have to do. So if I didn't mess that up, we should be able to run that test. So I can do that from the ID, or I can use the command line. So I'm going to use the command line for now, just to show you what happens, because it's easier to see from the command line rather than the ID. So there you go. So the test is running right now, and we can already see that it connected to Docker, and that's because it created a test container for my Postgres container. It's a bit slow. I don't know why. There you go. Build successful. So maybe you don't trust me. So I'm going to do asset equals.
Yeah, I don't. I never trust a test that I haven't
Exactly.
seen
Yeah.
failing. You
So
need to
I'm
make it
going to
fail,
do. So
and
I'm
then I
going
will
to do
trust it.
something else. Like I'm going to do fetched book, or I'm going to use book repository dot find by title, and then I'm going to use wrong name. And I'll set true that x is present. So if I do that, we agree that the test should fail, right?
Yeah.
Okay. So I'm going.
Yes, I assume so.
I would assume so too. So the test is running again. Connected to Docker, test container, and failed. Okay,
Right.
excellent. So what happened under the hood is what you can see there. So before we started the test, actually there was a process called the test resource service, and it actually introduced a Postgres provider as well as a generic test container provider. So basically what this service is capable of is provisioning test resources for us. And what is important to understand is that it's really a separate process. Like it doesn't run in the same VM as my test. It is separate and it has its own life cycle. So it means that I can do things like Gradle start test resource service. And it did exactly the same in the background, but now I have something running in the background. And this is the test resource server. If I do Gradle test again, this is going to connect to that test resource service and run my test. And we can see that test containers is used to execute a test. But now I have this container which is still alive. So if I run the test again, and I'm going to use clean test. Gradle is too fast. Like this finished super fast just because it just had to re-execute everything. So I can do rerun tasks. So that in action, like recompile, re-execute the test. Like still 3 seconds, pretty fast. But the test container which was used is exactly is still alive. So I can.
Right. So if you run Docker like PS or something,
Yeah,
we will see that, right?
you would because I don't have the rights for that. Yeah, you would see that.
Okay.
And actually, there's a service that you can query to see all the different test resources which are available, etc., etc. So in a nutshell, this is what happens. And for this to happen, you can see that my test is actually extremely simple. Like, it doesn't imply test containers at all. There's nothing which talks about test containers. And if we look at the configuration file of my Micronaut application, we can see that actually it's just saying I need Postgres, but it doesn't specify any URL. So you would typically provide a different configuration file like application-prod.yaml for your production database, and where you would specify the URL. But because in this context the URL is missing, this is the signal for the test result server to actually provision something and give that to you. So it's going to react to the fact that some properties are missing. So it's a super nice way to handle that. And so I was mentioning the GraalVM native image generation. So if I do this is going to generate a production image of my application, but this is not what I want to do right now. So what I want instead is something called native test. And what native test is doing is taking my test suite, which is there, 2 different tests, and it's going to compile that into a native test binary. So this test binary, you want the test to be executed within this test binary. And if we had to have test containers within the same VM, it would be extremely difficult to have a test binary which works. So I'm just going to copy and paste some configuration, just shading there for the sake of the demo, because in JUnit 5.9, there is a newly introduced behavior that we have to fix in the native plugin, actually. So this is why you have to write that right now. So it's basically, yeah, just have to. That's what you were mentioning about things which are difficult. So I'm just pasting that now, and I'm running the native test. And what it's going to do is to compile my native image, compile the test. So for those of you who are not familiar with native image, it can take several seconds to generate a native image. Like, the larger your application is, the larger the longer it's going to take, because it has to explore all the different paths,
So
etc.,
while
etc.
it's doing so, like when we
Yep.
compile a test, we also compile the application in the same binary, right? Because the test calls into like book repository and that.
Yeah,
Okay.
exactly.
Okay.
So it's going to
Nice.
reach everything which is reachable from the test classes, and
Including the assertions library.
including the assertions, including the test runtime. So
Right. So
so it's
if assertions would bring in Guava, there will be the
you would
the
get that
similar
in
clash,
the
right?
yeah,
Okay.
yeah, yeah.
Okay. Okay. Cool. 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 Cool.
But before, testing that was pretty complicated, because as soon as you have to reach a database, or I don't know, you have to start a Kafka server, whatnot, then it's complicated to make this happen within a native image. So
Yes, I know.
with the test resources now, what you get is that, because the process which is going to handle the test resources is separate and running in pure Java, it's not a native binary in this case. It just works. Like, this native binary is connected to the server and then executes all the tests. So we have test found and test successful.
Yeah.
So how to test.
Right. And
So
this tests the actual like database driver, so it doesn't kind of substitute those
it does
important parts
not.
of code with like mocks or with anything like that, right? So it's
Exactly. So
and
yeah, typically in test containers, you have these special drivers that you have to use. In this case, you do not use the special driver. You just use your regular driver, and that's it.
right. No, I didn't mean test containers. I meant more like
Okay.
H2 or
Yeah, no, no, no,
assertion.
no, no. It's yeah. That's something that we often mention in Micronaut. So you want to test your application with your actual production database. Like, you don't want a different behavior. It's a bit weird to test with a different behavior. And that's why it's important to have mechanisms like that to spawn your different containers. And we support, obviously, we support all the major containers that test containers supports. But with test resources, you also have conventional ways to declare that you, well, just in configuration file, you can declare that you want a new container, which is going to feed these properties, etc., etc. So it's actually pretty open, and we try to make it possible to configure things like mounts, exposed ports, etc., etc., just with this YAML file in this case. So
Right. Yeah,
so zero
it
code.
is pretty convenient. Zero, zero code,
Yeah.
which is to everyone their own, right? Some people prefer programmatic API to declare those things, and then since here you defer the actual usage of the test containers libraries to the test resources, then you need some sort of configuration way to do this.
Yeah.
We have a question. We have a question in the chat.
Uh-huh.
So if you need to specify the database dialect, and you support different types of questions, different types of databases, can you do that with just config changes? And
So not currently. So Micronaut Data requires you to have the dialect on the type. So this is because we do everything at compile time. So basically, the methods which are generated are different depending on the dialect. So there's a bit of duplication between the dialect that you use there and the one that you declare in the YAML file. Actually, this one can be inferred. So yeah, if you want to use different databases, you have to create different repositories. That's the
right.
limitation for now.
Okay. Yeah, I see.
So
I
maybe
understand.
I can show you this example I was mentioning earlier. Like if I search by me and try to compile my application, GraalVM test, this is going to fail compilation with an error telling you, hey, sorry, this property doesn't exist on the book class. So you get this feedback immediately at compile time, which is super nice.
That's amazing. That is pretty amazing. Yeah,
So
I think Micronaut Data is one of the very fascinating projects in the Micronaut ecosystem.
yeah. So I just wanted to show you, because test containers is not the only thing which is supported by test resources. So we use test containers internally, but actually you can create your own test resources if you want to. And if you use Gradle, which I would recommend to use in any case, it's super trivial to do this. So I just want you to show you this small demo there. And there's a GitHub repo that you can open to say that. But I have this greeter class there, and it uses this configuration property, my username, right? So if I say nothing in my application there and that my username is not declared, this
Right.
would normally fail because it cannot inject a value which is not defined in my properties file or that I do not inject. So I still want to test this class, and I assume that when the application is going to run, this property has to be set. So I can actually implement a test resource which is going to feed this property. And for this, you can have a separate source set, which is the terminology in Gradle, which is test resources, Java, and then you can implement your own test resource. And this is just basically implementing a single interface. And the simplest thing that you can do is this, like when it's trying to resolve that property, my test resource, then I can return a dummy value. So in my test, when this is going to execute, it's going to use my resolver to resolve this property. So actually pretty nice, if it makes
Right.
sense.
So if I would want to have a test resource that spins up an instance of something that isn't provided by Micronaut test resources out of the box, I
You
would
can
implement
implement
my
your
test.
yeah.
Yeah. So, and that resolve method would sort of be when I'm trying to resolve a property, say JDBC URL or my, do you have a test resource for local stack, like for AWS thing?
So we are working on the local stack support. For now, it's not supported just because we don't have any Micronaut module which actually uses those properties. But it's
Right.
we actually have a community
Right.
pull request to do that.
Right. So I would imagine, like, if something tries to resolve the property of AWS or something like
Yeah,
endpoint, then I would spin up a local stack Docker container using test containers, and then
yeah,
configure and feed the properties back into my
exactly.
application for how to use that particular instance. That
And
is
the
super
good thing
sweet.
is that this implementation that I showed is just in case you cannot do that via configuration. Because in most cases you don't even have to do code. Like if it's just a container that you have to start, you don't have to write any code. You can do that declaratively in the YAML file.
Right. Well, yeah. But you have also the full flexibility there.
Yeah.
That is pretty spectacular.
So maybe if you want to, I can show you the use case we were talking about when I had to fix a bug on the Windows.
Oh yeah, that'd be
And
pretty sweet. So
okay,
before, and
so
just a little bit of context, before the session started here, Cedric was talking about how he stumbled upon on the bug, and then he resolved it, and that was an
yeah,
interesting story enough for us to include this in the stream.
exactly. So the context is I was working on test resources and someone had an issue on the Windows and was mentioning that it didn't work. So I was like, okay, I'm using Linux. I need to debug the thing in the Windows, and that's scary, right? So I have this virtual machine which is using Windows, but the problem I faced is that Docker doesn't work on the Windows. So this project that I showed before is actually checked out in my VM, and if I do Gradle test here, you can see that it's starting my test result server, but then it blows up. And the reason it blows up is because I could not find a valid Docker environment. And I was like, shit,
Yes, of
how
course
can I fix that?
you need a Docker
So
environment
this is
for
where
test.
actually, yeah, you provided me with an solution to that with the test containers cloud, because the only thing I have to do is basically start this client, this containers cloud desktop, and then run it again. Gradle, oops, not this one. Gradle test. Gradle test. And now the tests are starting. And the reason they're
Right.
starting is basically because everything happens remotely on the containers cloud. So this is really awesome. Like it saved me, literally. And you can see
Right.
that it's
Yeah.
pulling the image, but it's not on my machine. It's doing that on the cloud. So you can talk about that for for me, but it really saved me.
No.
So
It is a
kudos on that.
pretty convenient that there are no challenges with any like Docker setup, whether you need to run it in PowerShell or in the Windows Linux subsystem or like your IDE and connect those. There are several moving parts there in typical usual setups, and yeah, we hope that with Task Containers Cloud, the setups are simplified like by a lot, and it just
Yeah,
works out of the box every single time. And you can see that the container is started and the tests are running, and uh, it took a little bit of time because it had to download
exactly. Yeah.
the images. But if you run it again,
But again,
I'm
I
sure it
could I
will
could
be.
use exactly the same behavior. Like I could do start. Sorry,
But
because my
you can just run it again because now it will be in the local cache, like just using the local Docker
yeah.
cache.
But even better if I do that. Like if I start the test result server, actually it's going to stay alive.
All
So
right.
the actual machine is still alive. This test is going to use MySQL. Anyway, we don't have to wait,
Right.
but the
No,
just going to.
this is great feedback. Thank you for sharing it with us, um,
Yeah, sure.
and thank you for
So
very
sure.
positive words about Task Controls Cloud saving your saving you
It
from.
really did. Like, this is crazy. Like, so this is not the only use case I had. Like, the other one was because I have a slow internet connection. So I was also mentioning to you that I'm actually using my 4G connection now. Otherwise, it wouldn't be possible to just talk to you. And like, when I had to download images, Docker images locally just for tests, like, it took ages. Like, instead
Right.
of doing that, I can just run the test containers cloud and have the bandwidth elsewhere.
Yeah, this is another benefit, right? Because in the cloud
Yeah.
there are a ton of resources. Right. So let's go back to the test resources. Does do Micronaut project like Micronaut Data use test resources now, like sort of immediately, or is there like a plan for migrating, or is it like sort of
Yeah,
by
so we
default enabled
started
now?
the dog food things, of course. So yeah, Micronaut, I don't remember if Micronaut Data is using that. I think it is now. But yeah, the project are slowly using that. So the difficult part is the setup. Like, we provide this Micronaut Gradle plugin, and the test result support is provided by this plugin. But our plugins that we use in Micronaut to build Micronaut are not the user plugins. Those are internal plugins. So sometimes we have to update the build to make it possible to use test resources. But the idea is, yeah, to use that as much as we can everywhere. So dog food everything.
Right. That is smart. That's most projects that can do that, I think should do that. That
Yeah.
makes a lot of sense. So we are at the end of an hour. Maybe a quick question: does Micronaut want more contributors? Do you want the community to join in? Are there any resources or guides like
Yeah,
how
yeah,
people can
sure.
help?
Yeah, yeah, of course. So the good thing about Micronaut is that if you go to GitHub/micro-projects, you have those many different projects I was mentioning. So Micronaut Core, Micronaut Data, Micronaut Kafka, whatnot. So if you're interested in a particular module and want to implement support for something which is not supported yet, we are more than happy yeah, to help you getting started, give you some resources. So yeah, we when you go actually to launch .micronaut.io, we actually show the modules which are officially supported and the ones which are supported by the community. So we make a difference between the two. And and of course, yeah, you can contribute to the official plugins too. Like, makes sense.
Right. Perfect. Perfect. Uh, right. Thank you for the episode. We had a few questions in chat, so if you
Hmm.
are fine, we can just go back through that. And
Yeah,
some
yeah,
of them
sure.
were about Micronaut, but by then we kind of moved to different stuff, and then
Hmm.
the time has passed. So, do you have any plans for providing the code hot reloading feature with Micronaut? That was a question by Siva.
So we have ideas, not concrete plans. So one of the reasons is that well, Micronaut is pretty fast. Like, startup time is crazy. Like, the everything that I showed you, like the test, it starts the whole application. Like, this is the whole application running. And well, I didn't show that in the demo, but you can, even with Gradle, you can use this -t, which is continuous mode. And every time you make a change to a production class or whatever and hit save, it's going to recompile and reload the test and re-execute the test. And it just does that in seconds. So we didn't really have the strong requirement for doing hot reloading. Like, we're still discussing
Right.
whether it's important to support this use case, knowing that dealing with class loaders is fun, you know.
No, I know it's not. It's I know, and it's not. It's not. Actually, this is reminds me of another question that we didn't cover, at least in the demo, but I just want to make sure. So Micronaut Test Resources, when I can use the same setup with them during my local development. So if I just check out my application and do Gradle run, is it Gradle run?
Yeah. If you do Gradle run, it's going to start the application, and it's going to start that in a special mode, which is the development mode. So if you do actually Gradle-T run, so it's going to start in continuous mode, and then you can make change to your production code, save, and it's going to reload. And the nice things about the test resources is that if you have a database, then you won't pay the price of spawning the container every time. So you just start your application, developing your application, you make your changes, and the database is still there. So it's super nice.
Right. Yeah. Yeah. So I can just clone my project. I can run my project immediately and make changes and run tests, and it will reuse this ephemeral setup that Test Resources created with test containers. That is pretty cool. That is really, really sweet. I think that is exactly the type of changes that you mentioned in the beginning, where it simplifies something that developers struggle with by a ton, and enables just a much more convenient workflow.
So there are many things that we could show with the test resources, but this one, which is really about live coding basically, and making some changes and not paying the price of spawning containers. This is one of my favorite use cases. So
yes, yeah. I understand. Well, thank you very much.
Thank you.
I want to congratulate you on the test resources release. And
Thanks.
I think it's a very, very neat implementation. And I'm very interested in seeing where Micronaut will take it further. Thank you, everyone.
Thank you very much.
This was Cédric. Find him online. If you didn't have a chance to ask questions, find him online, ask him questions about all the technologies that were mentioned. Go to GitHub, create discussions, pull requests and issues, and participate in the Micronaut community. And remember to test your code. Right. Thank you, Cédric, very much. It was a pleasure to have you. And to everyone watching, see you next time.
Bye-bye.